Let's look at solving limits through algebra rather than by analyzing a graph. And the different techniques I'm going to focus on in this lesson are direct substitution, where you just plug in what x is approaching. You can sometimes factor and cancel something in numerator and denominator. And in those cases, you can, on occasion, use long or synthetic division instead. You can rationalize either the numerator or the denominator. Or if those three don't really work, there is this catch-all that I put in here called other algebra, where you just do something else. Okay, so moving on. Let's look at some examples. And the first one is the easiest type of limit you can encounter, because for this one, when you do direct substitution, so we would have 3 times 5. I'm just substituting the 5 that x is approaching in for x in the equation. 3 times 5 minus 7. Raise that to the 2/3 power and do the arithmetic. 3 times 5 is 15, minus 7 is 8 to the 2/3. And when you are working a rational exponent, I think it's easiest to consider the denominator first. So I'm going to do 8 to the 1/3. I'm going to focus on that 3 in the denominator, and then I will square that answer. 8 to the 1/3 is 2. Same thing as cube root of 8. 2 squared is 4. And there is your answer for number 1. Number 2, I'm going to try direct substitution, just like I did with number 1. So we'll see what happens. 3 squared is 9. Minus 8 times 3 is 24, plus 15. And then my denominator, which we can already look at this and know there's going to be a problem, because 3 minus 3, you can very quickly tell that that's going to be 0 in the denominator. However, you don't want to stop by just knowing that 0 is in the denominator, because the numerator is equally as important. And when you work out the numerator, you get a 0 on top also. And 0 divided by 0 is something that we call an indeterminate form. Indeterminate. There are multiple indeterminate forms. 0 divided by 0 is one of them, and it's the only one we're going to focus on today. Indeterminate form, right now, we're just going to say that means 2 things. It means do more work. So we're going to do more work. And for now, that more work means that something is going to cancel. We will eventually be able to cancel something on top and on bottom. Eventually, we're going to learn a technique called L'Hopital's rule when we get further into calculus, but we don't have the tools to use L'Hopital's rule yet. So for now, 0 divided by 0 means do more work. It does not mean the limit does not exist. Sometimes, and I would say most of the time, an indeterminate form ends up giving you a real number answer by the time you're done. So in this case, the more work, I notice that I have a quadratic on top. I can factor that. And my numerator will factor to x minus 5, x minus 3. And my denominator is x minus 3. I can cancel the x minus 3's. And at that point, I'm going to try to substitute one more time. And if I substitute the 3 in for the remaining 5, or I'm sorry, for the remaining x, I have 3 minus 5, which gives you an answer of -2. And there's your answer to that limit. So this indeterminate form ended up factoring and canceling, giving you a -2 for the answer. Let's look at number 3. Let's direct substitute here. -2 squared is 4 minus 4. So I have a 0 on top. -2 cubed, -8 plus 8. So I have a 0 in the denominator. And so in this case, I'm going to again see if I can do some type of algebra. So I'm going to try factoring. Top is easy. Limit as x approaches -2. Top will factor to x plus 2, x minus 2. My denominator will factor 2. And here's one that a lot of people struggle with, factoring cubes. And I'm going to slap over here a formula for factoring cubes. So a, and this one is plus another cube. So if you have something cubed plus something cubed, and 8 is 2 cubed, that will factor 2, a plus b, a squared, minus ab, plus b squared. And so in this case, that's x and 2 for a and b. So it's x plus 2, and then x squared minus 2x plus 2 squared is 4. And now I can cancel the x plus 2's. And that x plus 2 is where the issue was. That is what was giving me my 0 on top and bottom. So once those x plus 2's are gone, I can now substitute into the remaining x's. This is -2 minus 2 is -4 on top. -2 squared is 4. -2 times -2, that'll be a +4 plus a 4, and that will reduce to -1/3 in the end. So there is our answer to that one. Let's go on to number 4. So if I plug in x approaches 4, so 4 minus 4, my numerator is 0. my denominator. Root 4 minus 2, that will be 2 minus 2 is also 0. So here I have another 0 over 0. I've got to do more work. Something's going to cancel. But this time, factoring is not an easy solution. It actually can be done. And I'll show you really quickly, maybe sometime later, how to do that. But this one has a square root term in the denominator. And so what I'm going to do is I'm going to rationalize my denominator by using the conjugate. So I'm going to use root x plus 2 on top, root x plus 2. And I'm going to only multiply out the denominator. And if you remember, when you multiply conjugates, that just means the terms are the same. However, the sign that separates them is different. So a plus b and a minus b, that will always expand out to a squared minus b squared. So when I expand that denominator, root x times root x is just x. Negative 2 times positive 2 would be negative 4. So that'll expand x minus 4 on bottom. Do not expand the non-conjugate pairs, because I want to leave this x minus 4 in the numerator intact because I want to cancel it. If you expand these on top, you're going to get rid of the easily cancelable term. So leave the numerator as is. We only expand the conjugate pairs, which in this case are in the denominator. So it gives me limit as x approaches 4. I will cancel the x minus 4s. And now when I try direct substitution, 4 in for the x, that's going to be square root of 4 plus 2, which gives you a final answer of 4. Let's connect to my 4. There we go. All right, so there was a few examples right there. I want to show you this time not just how to solve the limit, but how to show appropriate work. Because if you are going to take the AP exam and you solve a limit, if you do some fuzzy math, even if you get the right answer in the end, they will deduct points for, they call it a linkage error to be technical, but you have to show your work appropriately. And so what I'm going to do right here is show you how to write your work incorrectly and see if you can realize where my issue is and what's going wrong. So I'm going to very quickly plug in 5. 5 squared minus 25 is 0. 5 squared minus 6 times 5 plus 5 is also 0. So I now know that this is indeterminate. And I see these are pretty easy quadratics. I can factor these without too much problem. So I have x plus 5, x minus 5. Whoops, that goes on top here. Womp, womp. X minus 5. And then in the denominator, x squared minus 6x plus 5 is x minus 5, x minus 1. And so I'm looking at that and I see, there's my cancel terms. I had a 0 over 0. I knew something would cancel. So now I'm canceling my x minus 5s. And once you cancel, you do direct substitution. And I have, I'm approaching 5. So 5 plus 5 is 10. 5 minus 1 is 4. And if you're feeling smart, you can reduce that to 5 halves. And that is the correct answer. So 5 halves is correct. And if this were a multiple choice problem where work is irrelevant, then there's no problem with what you did, no issue with what you did. If this is a free response question, and I've graded AP free response exams for 2 years now, this would lose a point because there's an incorrect linkage from here to here. That is not exactly two things that are equal. Those are not two things that are equal. And the best example I can give you as to why that is incorrect is to go back to, say, Algebra 1, and you're working on order of operations. What if I told you to find the square root of 4 times 5 plus 5? And that's times. Let's use parentheses. Well, you could look at that and say, okay, well, 4 times 5 is 20 plus 5. 20 plus 5 is 25, which is true. Then you go back and you look at the original problem, and we're doing the square root. The square root of 25 is 5, and there's your answer. You got the right answer. 5 is the correct answer. However, if you look at your linkage here, when you're working from left to right here, I have a bunch of equal signs. At the very end, I made the profound statement that 25 is equal to 5. And it's not. That's an error. That's an error in presentation. It's not 25 equals 5. It's the square root. And you don't drop the square root symbol until you actually perform the square root operation. All these intermediate steps were me working on the inside. It's no different with limits. So this is wrong. What I need to do is, until you actually do the direct substitution, when I actually substitute 5 in for the x, that is when you drop the limit. This first step, I'm simply working on the inside the same way I was working on the inside of this radical. So I should have rewritten the limit as x approaches 5 right here. Now it's correct. You don't just work on the inside and ignore the limit, keep it in your head, and substitute in the end. So make sure that you write the limit as x approaches 5 in every little bitty step until you actually do the direct substitution. And so I'm going to fix this really quick. Shrink this up. I'm going to move this equal sign over. And so now I'm going to write the limit as x approaches 5. And now my work is correct. I don't need to put a limit on this step because from here, from this first step in blue to the 10 over 4, I actually did the direct substitution. So we don't need to write limit once you actually substitute. But you must continue to write limit as x approaches until you actually do the direct substitution. May have spent a little bit too much time on that. However, I wanted to make sure that you are writing your math in grammatically correct terms. So there are grammar rules to math, and I expect you to follow those. So let's go on. I think 3 or 4 more examples we're going to go through. This one, I may do these kind of quickly. X approaches 3, that's the square root of 3, minus 2 is 0. 3 minus 3 is 0. Something's going to cancel. And once again, I see a radical term. And so if there is a radical term, I'm going to try rationalizing. And you always do the conjugate of the radical expression. So I have root x plus 1 minus 2, the conjugate. We keep the radical the same, root x plus 1, except we'll make it plus 2. And we'll multiply that in the denominator as well. And so when I expand that, now I'm doing algebra. I'm not going to, I'm not direct substituting yet. So I'm going to rewrite limit as x approaches 3. I do not expand the non-conjugate pairs. So I will leave my denominator exactly as is. In my numerator, however, I will expand. And when you expand conjugates, you only have to multiply the first and the last. So root x plus 1 times root x plus 1 would be x plus 1. And then it'll be minus negative 2 times 2, that's negative 4, so minus 4. And if you look in the numerator, you can see that x plus 1 minus 4 is x minus 3. So I can cancel the x minus 3 on top with the x minus 3 on bottom. If everything cancels in the numerator, I like to put a 1 placeholder so you remember that we actually do have a fraction. And now I'm going to do my substitution, so I don't have to write limit anymore. My numerator is a 1, my denominator, root 3 plus 1 plus 2, and my final answer is 1/4. Let's look at this one. Now, number 6 here, this is going to fall under the other algebra heading. If we look at this, notice it is h approaches 0. So when you do your direct substitution, we substitute for h. H is the variable as far as this limit's concerned. So if I plug in 0 for h, I will have x plus 0, which is x squared minus x squared over, and I'm plugging 0 in for h. And that does give me 0 over 0, which means something's going to cancel. Now, this limit, if it doesn't look familiar from last year, this limit is the limit definition of a derivative. And in these h approaches 0 limits, especially if it's like algebraic, like here it's a binomial being squared, something like that, you're going to completely expand that. So x plus h squared is x squared plus 2xh plus h squared. Then I have a minus x squared left over here. I have an h in the denominator. And you should, when you fully expand the numerator in these problems, everything without an h should subtract away. And I do have x squared minus x squared. Those subtract out. And I'm left with 2xh plus h squared over h. Now, I have not substituted, whoops, this should be an h. I have not substituted 0 for my h yet, so I continue writing limit as h approaches 0. And in this problem, I notice I have h's in both terms on top. We will factor the h out of that, leaving you with 2x plus h all over h. I still have not substituted h equals 0. I keep writing x. H approaches 0. Now I see that I can cancel these h's. Once I factor that h out, it's h times stuff. I can cancel this h with that h. And at this point, I can do the direct substitution. Once you cancel, that's when you go back to substitution, and I'm plugging in 0 for the h. So this will be 2x plus 0. And if you remember your plus 0 tables, The answer is 2x, and sometimes the answer to a limit does have variables, especially when you start with multiple variables. And let's see, I think one more example. Yes, one more. So x approaches 3, 1 over x minus 1/3 over x minus 3. And so if I do direct substitution, I can already tell 1/3 minus 1/3 is 0. X minus 3 is also 0. So I'm going to have to do some type of algebra on this problem. Doesn't factor. I don't see a radical, so I can't use conjugates. So I'm now down to the other algebra. And what I'm going to do, there are two ways to do this one. I'm going to do a little trick here. I'll look at all of the individual terms in my big fraction. I have a 1 over x, a 1 over 3, an x, and a 3. I'm ignoring the negatives in front of the 1/3 and the 3. So I have those 4 terms, and I want to find a common denominator for those 4 terms. So if I were to pretend I were adding all of these, they have a common denominator of 3x. So my common denominator for all 4 terms is 3x. I'm going to take this big fraction, I'm going to multiply the numerator by 3x, and I'm going to multiply my denominator by 3x. Okay? As long as you multiply numerator and denominator by the same thing, you're okay. You can always do that. It's because 3x divided by 3x is 1. I'm essentially multiplying by 1. And when I distribute that 3x through the numerator, I'm only going to multiply it through the part of my problem that has fractions. So I have 1 times 3x over x minus 1/3 times 3x, which would be 3x over 3. My denominator, I am not going to expand. I have x minus 3 times 3x. I have not substituted yet, so limit as x approaches 3. Now I can cancel my x's. I can cancel my 3's. And in the numerator, still have to write limit. I have not substituted yet. In my numerator, I have 3 minus x. In my denominator, I have x minus 3 times 3x. And you can cancel from here if you want to. 3 minus x and x minus 3 can cancel. However, it might be safer so you don't make a sign error to factor a -1 out of the numerator. Because if you notice, these are exact opposites. If you factor a -1 out of the numerator, that will turn my numerator into x minus 3. Now my denominator, x minus 3, 3x. And now I can cancel the x minus 3's. Don't forget there is a -1 hanging out up there. And so my final answer, here's my direct substitution, so I don't have to write limit anymore. -1 over 3 times 3 is 9. There is your answer. I typically, on problems like this, where I notice I have something on top and bottom that are exact opposites, 3 minus x and x minus 3, I will usually skip this step and go straight to there. So there are some examples of solving limits with algebra. Hopefully that made sense.